Hi there, this is Cameron Ogden, Head of Solution Management at Datum, and I'm going to be taking you through a video series to give you an easy introduction to artificial intelligence, machine learning, and deep learning. We'll also talk about what these topics mean for data governance and big data. So this series is geared towards a non-technical audience that might not have a background in computer engineering, data science, or statistics. What we're going to do is provide a high-level overview of AI and machine learning concepts that will span across several videos in the series. So in this first video, we're going to cover the basics of explaining what is artificial intelligence and various forms of machine learning and deep learning. And in part 2 in our series, we'll get into some detail and easy examples to explain how machine learning and deep learning work. And in part 3 in the series, we'll connect the dots to what AI and machine learning hold for the future of data governance and big data. Well, it seems like everywhere you look, there's a lot of hype about the promises of artificial intelligence. Since AI has moved into the mainstream, it's easy to get carried away with claims of everything that AI is. So let's take a second to talk about some of the things that AI is not. First, AI is not the same thing as machine learning. AI and machine learning are terms that always seem to be used interchangeably, but there are some important differences to understand. Machine learning is actually a subfield of AI, and we'll talk more about its defining characteristics later in this video. Second of all, AI is not what we see in the movies or in science fiction. AI is focused on simulating problem solving in the way that humans think, and that's very different from stories of robots that might want to take over the world. And lastly, AI isn't something that's new. While the origin of AI can be debated, the first real breakthroughs occurred back in the 1950s, so AI has actually been around for over 60 years or so. The picture on the right is of a guy named John McCarthy, who is known as the father of AI. He actually coined the term of artificial intelligence, and he, along with a team of researchers back in 1956, defined many of the central goals of AI, which we'll talk a little bit more about later on. Artificial intelligence, machine learning, and deep learning. Let's bring a little bit of clarity to how these terms relate to each other, as you will no doubt hear them used interchangeably, but they're not the same thing. Artificial intelligence is the broad, overarching field in computer science referring to any simulation of human intelligence in a machine. Machine learning is a subfield of artificial intelligence, and it specifically applies to systems that learn from experience. So when we say experience in the case of machine learning, what we really mean is data. So machine learning are systems that learn from data, which, as you can imagine, will really highlight the importance of data governance, which we'll talk more about in part 3. Deep learning is a form of machine learning, and for the purposes of this discussion, deep learning is based on a concept called neural networks. Neural networks are modeled after how the human brain works. So the human brain thinks in layers, and deep learning is modeled the same way by using many layers made up of things called neurons to identify patterns and trends in a data set when it doesn't have any clear relationship or structure on the surface. So to clarify, AI is a computer science field that refers to any simulation of intelligence in a machine. Machine learning is a subfield of AI that refers to machines that learn from data. And deep learning is a form of machine learning that uses neural networks to solve complex problems. One final point, you should know there are other forms of AI and machine learning methods that are out there. But to keep things simple, we'll focus on these 3 terms in our series, since they're the most popular ones and cover the majority of examples in the real world today. Now, what you may or may not recognize is most of us already use AI in our everyday lives. For example, anytime we run a search on Google, we're summoning hundreds of Google algorithms to rank the importance of website pages. The spam filter on our email, that's using machine learning techniques to filter out junk mail. Photos on Facebook or on your cell phone that identify friends and family members, that's deep learning image recognition at work. And anytime we shop online and are greeted with other products or services that we might like, those are examples of recommender systems that are based on machine learning algorithms. So all these are examples of AI, machine learning, and deep learning techniques at work. And AI is already being used pretty much everywhere to enrich the experiences and services in our everyday lives. On the business front, AI is also being used in a number of capacities, and most of the companies we work with at Datum have intentions to explore how AI and machine learning can be used to solve a number of their business problems. In part 3 of our series, we'll talk a little bit more about practical applications of AI as opposed to hyped applications, but there are a number of useful examples that we can highlight here. For example, manufacturing companies are using AI to automate production tasks and reduce waste. You probably have heard stories on how Hershey Foods is using AI to reduce waste in the production of Twizzlers in one of their factories. Brick and mortar stores such as Lowe's are exploring the use of store bots to help customers find the products that they need. Retailers are using facial and image recognition to reduce the risk of theft in their stores. And several industries are using AI to make better forecasting decisions by monitoring social chatter and conversations on Facebook and Twitter that might indicate the hype of an upcoming product, a service, or a trend. So we know what AI means, but let's talk about what it actually does. These are the central goals that John McCarthy and others defined when they first explored the idea of artificial intelligence and what it could do. It turns out that the original researchers were actually pretty visionary because, for the most part, these qualities appear in almost all of AI, machine learning, and deep learning technology today. So let's go through these one by one. Reasoning. This is when a machine is presented with a problem and it reasons its way to an answer. So an example of this is, think of the chess program Deep Blue that beat Garry Kasparov in chess a few years back, who was the world champion at the time. Knowledge representation. This is teaching a machine to represent knowledge about the real world. So things like, what are objects? What are categories? What are the relationships between them? What is the cause and effect? Planning. Planning includes things like how to get from point A to point B. What is a route? What is a path? Where is it safe or unsafe? And certainly this is used by GPS navigation today in things such as Waze and Google Maps. Natural language processing. Another goal is to have machines understand language or speak a language and understand its context. Most people are familiar with this today through voice to text or Siri on the iPhone, or even in-home devices like the Amazon Echo. Perception. Yet another goal was for machines to see things, hear things, and touch things in the real world. So this is used in automated machines on a production line, as an example, and also self-driving vehicles. And then lastly, generalized intelligence. This is somewhat of the holy grail of artificial intelligence. And generalized intelligence means that machines would be able to combine all of these qualities together into something that could have moral reasoning, have emotions, and have feelings. And in this way, the thinking was that machines could better understand people, and people could have a better understanding of machines to make for a more enriched life for humans. So while we're not at this stage today, this remains one of the top goals of AI and machine learning. Well, we know that AI has been around for 50 or 60 years, but there's also something really important to know about the evolution of AI and machine learning over the past half century. AI has actually been through several boom and bust periods since its first major discoveries back in the 50s. The first boom came in the early 60s, the second boom around the early 70s, and the third boom period came in the 80s. It's interesting as a side note to see how pop culture reflected these periods. First with things like The Jetsons, Westworld, in 2001, A Space Odyssey, and then later on with movies like Tron, Blade Runner, The Terminator, and so on. Anyway, the bust periods that followed actually have a term called an AI winter. An AI winter refers to the points in time where the promises of AI just didn't measure up to its expectations. And a lot of people abandoned the notion that machines could ever learn like humans. We've been through at least 3 AI winters over the last 60 years, but we're back in an AI boom period, and things are very different this time around. So why does everyone think AI is finally here to stay? There are several reasons. First, it takes a massive amount of computing performance to train the sophisticated algorithms that power these new applications. That's a huge challenge. Computers today are roughly 300 million times faster than they were in the 80s. Yet training can take days to weeks on even the fastest computers today for the most demanding deep learning neural nets. Second of all, we now have the data. AI and machine learning feed off of data. The more data you have, the more information the program can use to train its algorithm. So since everything is creating data now, from wearable devices to cell phones to in-home personal assistants, we have oceans of data to now potentially find answers to almost any question in our physical world. We'll talk more about this in part 3 of our series, but you can see the huge impact that this has on data governance and various data governance use cases. Thirdly, better algorithms. Instead of programming AI programs using rules and expert logic, we've capitalized on decades of research to mature algorithms to the point where they learn from experience using techniques like neural networks. And lastly, there is broad investment across all domains in AI, machine learning, and deep learning. Whereas AI was largely only explored in the academic and research space in the past, we now see nearly every organization interested in ways of how they can potentially use machine learning to solve complicated problems. So let's close by taking a second to talk a little bit more about deep learning. Deep learning is probably the biggest reason why we've had so much breakthrough around AI over the past couple of years. I mentioned earlier that deep learning is modeled after the way that our brains think. We see things in layers, and what I mean by that is when we see a dog, our brain uses a network of neurons to know that a dog is a living thing, an animal, and ultimately a dog. And if that dog were to be on a leash, we know that primarily we're looking at a dog instead of looking at a leash. Deep learning uses algorithms to recognize patterns and trends in the data in the same way. Neural networks have layers of machine learning neurons, which is why it's called deep, because of the layers. And they all connect to each other as part of the larger problem-solving algorithm. So deep learning is the main reason why AI has made so many advancements over the past few years, and it has become somewhat of a silver bullet in solving almost any machine learning problem. That doesn't necessarily mean that you would want to use deep learning to solve everything, but it's been able to crack many of the problems that have vexed AI researchers for decades. We'll talk a little bit more about deep learning, including how neural networks work, in part 2 of our series. But for now, just know that it's based on how humans think and learn. And its breakthroughs recently have driven a lot of the AI boom. So artificial intelligence, along with machine learning and deep learning, it's here to stay and will have a great impact on the way we live and work together over the coming years. And data is absolutely the rocket fuel that makes it all possible. You can see why data governance is a key determining factor and how businesses capitalize on these new, amazing opportunities. We'll be talking much more about that a little bit later on in our series. For now, this brings us to the end of part 1. In our next video, we'll go a layer deeper and show you how machine learning and deep learning work.